In the years since 1945, air travel has expanded in leaps and bounds. There are now few places in the world which cannot be reached by commercial aircraft. Almost every independent state, however small, has its own airline. Indeed, the main reason why airlines are often called flag carriers is that they're high-profile ambassadors for their countries. The pace of air travel has also grown. Passengers being handled by New York's three major airports, JFK, Newark and LaGuardia, are some 80 million each year. There is too an ever-increasing amount of air freight being sent around the world. Yet at the end of the Second World War in 1945, the situation was very different. In many parts of the globe, civil aviation had ceased to exist. But the United States was well placed to re-establish civilian air transport. For a start, the country had suffered no physical damage as a result of enemy action. The infrastructure was still in place, and indeed had been strengthened. The Civil Aeronautics Authority, CAA, which had been set up in 1938, increased its powers during the war. It took over responsibility for air traffic control throughout the United States. Only the CAA could issue licenses for pilots to fly on instruments alone. Furthermore, the US Army's Corps of Engineers had built enormous numbers of airfields during the war, many of which were now handed over to state and local governments. Most significant of all, however, was that the development and construction of commercial aircraft did not cease during the war. This was not so in Britain, where aircraft production had concentrated on combat types, relying on the Americans to provide the RAF with transport planes. Initially, these were civil airliners, like the Douglas DC-3, which had proved themselves before the war. The DC-3 itself became the military C-47 Skytrain. Known as the Dakota by the British, this was the workhorse of the skies for the Allies. Douglas also had the long-range DC-4, which became the C-54 Skymaster. Likewise, the Lockheed Constellation, which was in development when America entered the war, became the C-69. The main American airlines also survived the war. Pan Am's famous Clipper flying boat service was rented to the Army's Air Transport Command, with its Boeing 314s regularly crossing the oceans. TWA's Boeing Stratoliners were put to similar good use. But Howard Hughes, TWA's proprietor, noted that Lockheed's production capacity for the Constellation was greater than the Army Air Force required, and obtained 10 before the end of 1945. The Connie, as it was known, could cross the United States in just 7.5 hours. However, at normal cruising speed, the flight time exceeded the aircrew limit of 9 hours. Hence, TWA had to operate its transcontinental service with a midway stop. Only the arrival of the Douglas DC-6 in 1947 broke the Connie's monopoly of long-haul flights across the USA. The US airlines were also able to rapidly expand their passenger capacity through the purchase, at a very cheap price, of surplus military transports. At the time of Pearl Harbor, American civil aviation had a total capacity of just 6,200 seats, the equivalent of a mere 20 of today's Boeing 747 jumbos. 5 years later, the total was 19,000 seats and rising rapidly. Even so, the Pullman train service was still the main passenger carrier, and the one significant obstacle to expansion of the domestic US air routes. The initiative to overcome this was taken by airlines outside the Big Five, the so-called non-scheduled airlines, which relied entirely on surplus military aircraft and offered no-frills flights at a very competitive price. By 1949, the major airlines were forced to follow suit. The result was a massive expansion of domestic air travel and a rapid decline in the fortunes of the railroad companies. In Europe, however, the situation was very different. Britain had just one airline, British Overseas Airways Corporation, BOAC, which had been committed to government service during 1939-45. To re-enter the civilian market, BOAC was initially forced to convert bombers into passenger aircraft. Thus, the Lancastrian emerged from the famous Avro-Lancaster bomber. European aviation was, however, helped by the Marshall Plan, the American economic package designed to put the continent back on its feet after the destruction caused by the war. This enabled European airlines to purchase US aircraft like the Constellation. Britain's BOAC also concentrated on rebuilding the pre-war Imperial Airways routes to the British Empire. They developed a new breed of flying boat, which culminated in the massive Saunders Roe Princess. But Pan Am, which had used flying boats extensively before the war, quickly realized that they were now obsolete. Planes like the Martin M130 had been overtaken by a new and much faster breed of long-haul airliners. The most revolutionary of the new long-range civil aircraft had its origins in the Boeing B-29 Superfortress, the longest-range bomber of the Second World War. The Boeing Stratocruiser entered Pan Am service in 1949. It could carry up to 100 passengers and had a maximum range of 4,500 miles. This enabled the Stratocruiser to fly the Atlantic with ease. But the keynote of this aircraft was its luxury. Nothing was too good for the passengers. They occupied the upper deck, but could go downstairs and enjoy a drink from the cocktail bar, which had comfortable seating for 14 people. Another aspect of the Stratocruiser was the ability to turn part of the upper deck into 20 sleeping berths, with 2 changing rooms, male and female included. The Stratocruiser's galley was the best equipped of any airliner of the day. All cold food was prepared on board, with preheated frozen food being warmed up in the galley. Intriguingly, the Stratocruiser was the first commercial aircraft in which coffee could be brewed in flight. Stratocruisers were soon in service with many airlines and would carry a total of 4 million passengers during their lifetime. But even more revolutionary civil aircraft were now to appear. At Britain's 1949 Farnborough International Air Show, no less than 4 new British airliners powered by turboprop engines, including the Vickers Viscount, were displayed. Unlike the conventional piston engine, in which much of the energy developed by internal combustion is wasted, the turboprop has a second turbine at the rear of the engine. This recovers much of the expended energy and also drives the propeller. The result is a much more efficient and quieter engine. But what really excited those who attended Farnborough in 1949 was the world's first pure jet airliner, the de Havilland Comet. While conventional airliners, including turboprops, had a maximum cruising speed of some 300 miles per hour, the Comet could cruise at almost 500 miles per hour. Its handling in the air was also very impressive. Sir Miles Thomas, chairman of BOAC, commented,
"As soon as the Comet came into my hands, it was evident she was a thoroughbred. She responds beautifully, riding the air smoothly and purposefully. She makes turns in graceful, effortless sweeps, as though held to a true curve on an invisible pivot. To compare it to an ordinary plane is like contrasting sailing with motorboating, ice skating with roller skating, pneumatic with solid tires on the road. The world shrinks in one's hands in this astonishing aircraft."
The Comet entered BOAC service in 1952, cutting the flight time from London to Johannesburg, South Africa, from 40 hours to just under 23 and a half. Airlines all over the world began to take serious interest in the Comet, and orders for it were placed. But it did have drawbacks. First, it carried only 36 passengers. Also, the Comet's range was such that it could not fly non-stop across the Atlantic. Worse, within months of entering service, a series of Comet crashes took place. Some were attributed to pilots lifting the nose too high during takeoff, thus preventing the aircraft attaining flying speed. This was overcome by drooped leading edges, which gave increased lift at lower speeds. Other crashes, however, could not be explained. In April 1954, a South African Airways Comet en route from Rome to Cairo crashed into the sea shortly after takeoff, with the loss of all on board. The Comets were grounded until the cause of these disasters could be identified. The Royal Navy was called in to salvage pieces of the South African Comet from the Mediterranean. They used remote underwater cameras to locate the wreckage. This was flown back to Britain for examination. It was eventually found that repeated pressurization and depressurization of the hull had brought about metal fatigue, and a radical redesign of the Comet had to be carried out. Meanwhile, in July 1954, the prototype of the first American jet airliner had made its maiden flight. The US aviation industry had first viewed the commercial jet as a gas guzzler, whose engines would be costly to maintain and aircraft range limited. This did not fit with the drive for cheap fares. The initial success of the Comet changed the industry's perception. Boeing, which had been studying commercial jet design since 1947, took the lead. They used the experience gained from their B-47 strategic bomber, first flown in 1947, and the larger B-52 Stratofortress. The result was the Dash 80, which became better known as the Boeing 707. The 707's swept-back wings gave the aircraft a speed of 600 miles per hour, significantly faster than the British Comet. It could also carry well over twice the number of passengers. But Boeing's longtime rival, Douglas, also fielded a jet airliner, the DC-8, which was slightly larger than the 707, but with much the same performance and configuration. Unlike the 707, no DC-8 prototype was built, with the first production model making its maiden flight in May 1958. The race between Boeing and Douglas to sell to the airlines was now on. Boeing had already sold a tanker version of the 707 to the US Air Force, and as the KC-135, it is still in service today. They hoped to sell the civilian version on the back of this, but the tanker sale had committed them to a military engine, the Pratt & Whitney J57. The powerful J75 engine now appeared and was fitted to the DC-8. It was Juan Trippe, the dynamic long-time head of Pan Am, who really set the ball rolling. He realized that the J75 would enable an airliner to fly the Atlantic non-stop, without refueling at Gander, Newfoundland, which was the normal practice. Trippe initially ordered 20 707s, since they would be ready earlier, and 25 DC-8s, but made it plain that he intended to sell the 707s once he had received his DC-8s. Other airlines also opted for the DC-8. Boeing therefore had no choice, if they were to stay in the game, but to radically modify the 707 to take the J75. The result was the Boeing 700-300 series, known as the Intercontinental. But Boeing also produced 707 variants to suit individual airlines. One model, the 707-200 series, was specifically designed to operate from high-altitude airports in South America. As a result, the pendulum began to swing Boeing's way, and soon they'd overtaken the DC-8 in sales. Indeed, the 707 was to achieve worldwide sales of nearly 1,000, almost twice that of the DC-8. In the meantime, other civil jets appeared on the scene. In March 1956, and much to the surprise of onlookers, an aircraft looking like the Soviet Tupolev Tu-16 Badger strategic bomber, one of the main players in the Cold War, landed at London's Heathrow Airport. It was, in fact, a civilian derivative, the Tu-104. A year earlier, the French had entered the market with their short-haul Sud-Est Caravelle, whose rear-mounted engines made it easier to handle if one failed. But the race to establish a transatlantic jet service was won by the redesigned Comet 4. Two of these, in BOAC colours, simultaneously took off from London's Heathrow and New York's Idlewild Airport on the 4th of October 1958. The westbound flight still had to stop at Gander, Newfoundland, however, because of the headwinds which predominate over the North Atlantic. Nevertheless, there was great excitement in Britain that a march had been stolen over the Americans. But it was to be short-lived. Just over 3 weeks later, on the 27th of October, a Pan Am Boeing 707 called Clipper America also took off from Idlewild. Like the Comet, it also staged at Gander, Newfoundland, before flying on to Paris's Le Bourget Airport. There were, however, critical differences between the two aircraft. The Comet 4 could carry a maximum of 76 passengers, and its extreme range of 3,000 miles was barely enough for a safe Atlantic crossing. The 707 could take 110 more people, fly 100 miles per hour faster, and could easily cross the Atlantic non-stop. It was no contest. Indeed, BOAC had already accepted this by ordering 11 707s, intending to use their Comets on shorter routes. Thus, by 1960, the 707 reigned supreme over the transatlantic air routes. A journalist put this new era of non-stop transatlantic flight between New York and Paris in a nutshell.
Leaving Fifth Avenue in the evening and stepping out onto the Champs-Élysées around noon the next day is a thrill already achieved by the miracle of aviation. But leaving Fifth Avenue at noon and pulling up a chair at a Parisian sidewalk cafe at midnight is an experience that must change everyone's estimate of the world. For 6 hours of that elapsed time represents the time difference between New York and Paris.
Yet while intercontinental travel had been dramatically speeded up, the coming of the jet airliner brought with it new problems and aggravated existing ones in the commercial aviation field. During the 5 years from 1954, air passengers on America's domestic routes had almost doubled, from 32 to 52 million. Airports were becoming overcrowded. There was too concern that existing runways were too short for the new breed of jet airliner, and that their noise was a subject of increasing complaint from people living nearby. Furthermore, air traffic control was finding it difficult to cope with the growing number of flights and with the faster speeds of the jet airliners.
4 off the left, advise, ready for departure. Okay, it's 7 rolling.
The answer to some of these problems lay in the turbofan, which was developed by the British aero engine company Rolls-Royce. This engine has a ducted fan to drive air into the compressor. But some air bypasses the engine. As in the turboprop, the turbine at the rear drives the fan. The result is a very much quieter and more efficient engine than the turbojet. This meant fuel savings over conventional jets and would extend the range of the 707 and DC-8 to some 4,000 miles, enabling them to reach all the major cities in Western Europe from the United States. Finally, the engine's greater efficiency meant that the big jets could take off from existing runways. Thus, by the early 1960s, the turbofan was rapidly taking over from the turbojet. The 1960s also saw an increase in the number of international airports, with more terminals built at existing ones in order to cope with the ever-spiraling number of people traveling by air. By 1970, a number of US railroad companies had been made bankrupt. Furthermore, the introduction of economy long-haul airfares in 1958 marked the rapid demise of transatlantic travel by sea. This had peaked in 1957, with over 1 million passengers opting for the pleasures of sea travel. 10 years later, those two famous Atlantic liners, Queen Mary and Queen Elizabeth, made their last crossings. The problem of air traffic control was more difficult to solve. There were two aspects to this: flight between airports and the approach to the airport. Controlling the rate of aircraft landings is essential. If too many aircraft land in a short space of time, the airfield becomes clogged. It also results in congestion in the arrivals part of the terminal, resulting in long delays for passengers reclaiming their baggage. The answer lay in a technique called stacking. Aircraft approaching the airport will be ordered by air traffic control to begin circling at height intervals of 1,000 feet. Once the backlog at the airport is cleared, the lowest aircraft in the stack will be directed to land, and those above it will each drop 1,000 feet and continue their circling until they are called in. The air traffic controllers initially relied on their skill at visualizing the stack, since there were not enough radars available. As stacks multiplied, the problems of controlling them increased. Only at the end of the 1950s, because of the sheer cost, were sufficient radars installed at airports to simplify the controller's task. As for navigating between airports, the system established was VOR, or Very High Frequency Omnidirectional Radio Range, although this is now being largely superseded by the satellite-based Global Positioning System, GPS. VOR consists of a network of radio transmitters constantly radiating signals, which are automatically received by the aircraft. If the pilot is flying along his selected bearing, his VOR dial needle will be vertical. The needle swings to the right if he is off to the left of his track, and in the opposite direction if he's off to the right. The pilot can also work out his distance from the VOR transmitter by sending a signal to it and computing the time it takes to return to the aircraft. It was also laid down that aircraft must fly along a specific corridor through the sky. Until the late 1950s, pilots would often do this visually if the weather was clear. But with airliners traveling ever faster, mid-air collisions occurred. Hence it was made mandatory to fly on instruments alone. Another solution to the problem of ever-increasing commercial air traffic during the 1960s was to build larger aircraft. This was initiated by Boeing with the 747 jumbo jet, which made its maiden flight in February 1969. Capable of carrying nearly 380 passengers over 5,500 miles, the 747 began commercial service on the Pan Am New York to London route. But Boeing did not have the wide-bodied field to itself. Douglas produced the DC-10 and Lockheed the L-1011 TriStar. Each was able to carry nearly 400 passengers. These two aircraft differed from the 747 in having 3 engines, with one mounted in the tail. They were slightly smaller, but cheaper to buy. Yet there were doubts as to whether airlines could fill the seats of this new breed of jumbos. To attract customers, the upper decks were turned into first-class dining rooms, or even casinos, and in one case, a dance floor. It was no good, and so the lower decks of the jumbos were made entirely economy class, with cut-price seats, which were 9 or 10 abreast. One British entrepreneur, Freddie Laker, purchased DC-10s and launched his Skytrain, which offered unexpectedly low transatlantic fares.
Welcome. Number one on Skytrain.
Eventually, the big airlines conspired against Laker by lowering their fares below his and forcing him out of business. Initial jumbo sales did not proceed fast enough for production costs to be covered. This was aggravated by the beginning of an economic slump in 1970. Consequently, Douglas merged with McDonnell, and Boeing was forced to close its Seattle plant in order to curb its rising overdraft. The effects of this step on the local economy were quickly felt. They were more than summed up by the notice, "Will the last person leaving Seattle turn out the lights?" Yet the jumbos not only survived, but spread their wings to all parts of the world. Today, a new generation of jumbos has arrived. The McDonnell Douglas MD-11 and the Boeing 777, both capable of carrying more people ever further. But during the 1960s, there'd been an even more sensational development in civil aviation. In 1962, the British Aircraft Corporation, later British Aerospace, signed an agreement with the French Sud Aviation, later Aerospatiale, to jointly design, develop and produce a supersonic transport, or SST, aircraft. Shortly afterwards, President John F. Kennedy announced that America too would pursue the SST concept, the project competition being eventually won by Boeing. But a third contender now entered the race. Soviet Premier Nikita Khrushchev wanted to capitalize on Russian successes in the space field and saw a Russian SST as a means of breaking into the American-dominated civil aviation market. It was the F-111 bomber, with its variable geometry swing wing, which inspired Boeing. They decided to incorporate this in their SST and designed an aircraft to carry 234 passengers at 3 times the speed of sound, Mach 3. The Anglo-French project rapidly took shape and was given the name Concorde. This aircraft was to be smaller than the Boeing SST, with a capacity for 128 passengers and a top speed of Mach 2. The design of the wing enabled it to land and take off at a high angle, thus permitting it to use existing runways. Concorde's movable nose was placed in the drooped position for takeoff and landing, so that the pilots could see, and then retracted into the horizontal position to enable the aircraft to fly supersonic. French Mirage 3 fighters were used to give potential Concorde pilots the feel for flying at supersonic speeds. The Russians were well aware of Concorde's good progress and set up an elaborate espionage network to obtain its secrets. In spite of being fed with some false information, they managed to obtain a complete set of technical drawings of the Anglo-French project. The result was that on the 31st of December 1968, the Tupolev Tu-144 became the first supersonic airliner in the world to become airborne. However, the Tu-144's likeness to Concorde was so striking to Western observers that the media dubbed it Concordsky. Just 2 months later, in March 1969, the first Concorde flight was made from its French headquarters at Toulouse. This was followed a month later by the British prototype. These test flights were very successful, and the future looked bright. In contrast, the Boeing SST was now in difficulties. The swing wind gave the aircraft an unacceptable all-up weight and had to be scrapped. This put the project 2 years behind schedule. Mach 3 was also seen to be overambitious as a top speed, and Boeing had to lower their sights. Subsequent test flights of Konkordsky also revealed a problem. Andrei Tupolev and his designers had been unable to reproduce an exact copy of the Concorde wing. They found that their version failed to give the required lift and stability throughout the speed range. To compensate for this, they attached small canard wings just behind the cockpit. These would come into operation at low speed and be retracted for supersonic flight. It was at the 1973 International Air Show at Paris, France, that the two rivals competed against one another in the air for the first time. On the 3rd of June, the third day of the show, Concorde gave its flying display. It was faultless. Konkordsky now took off, climbing very much more steeply from the runway than Concorde. The display was going well, and the pilot appeared to pull up to avoid a near-flying Mirage fighter and then went into a dive. Some 1,500 feet from the ground, the plane broke up, the wreckage falling into a group of nearby houses. This disaster not only dashed the Soviet chance of foreign sales, but was also to be the eventual death knell of the project. As for the Boeing SST, development costs had spiraled because of the design changes. Worse, the growing environmental movement in the United States launched a vociferous campaign against SST. Eventually, in 1971, Congress voted against the project. Without the help of government money, Boeing could not afford to go on, and the SST project was scrapped. Environmental objections also made it difficult to sell Concorde, and eventually only British Airways and Air France bought 8 each, a disappointment in the context of the optimism surrounding the signing of the 1962 agreement. The environmental issue made it especially difficult to get clearance for Concorde to land in the United States, which was crucial to its viability.
That abomination will never, never land at JFK Airport.
Despite this, in 1976, transatlantic flights to Washington, D.C., and then to New York got underway. Other routes, including to Caracas, Venezuela, and Singapore, were tried, but lost money or came up against environmental brick walls. Now, over 20 years on, Concorde still plies its way back and forth across the Atlantic in half the time of the conventional jet. It is as popular as it ever was. As for flying in it,
a flight in the Anglo-French supersonic airliner is at once exceptional and routine. Exceptional in the speed implied in the magic Mach meter figures displayed in the cabin, routine in the very ordinariness, albeit first-class ordinariness, of the flight itself.
Nevertheless, there is no other civil aircraft which has such a futuristic shape, and Concorde continues to thrill all who set eyes on it. The 1970s also saw a fresh expansion of civil aviation. This was through the use of airliners chartered by travel companies for their package holidays, which included both travel and accommodation at a very competitive price. Many who would otherwise never have dreamt of flying now found themselves doing so, swelling the numbers of air passengers still further. But the 70s also witnessed a new problem: the growth of air terrorism. Airliners would be hijacked in mid-air and forced to land at particular airports. The passengers and crew were held hostage while the terrorists, often from the Middle East, but sometimes from elsewhere, bargained with the authorities. Sometimes the aircraft themselves were destroyed on the ground, as happened in September 1970, when no less than 3 were blown up on a desert airfield in Jordan by Palestinian terrorists. A variation was placing bombs on board airliners. Sometimes, as in the case of this Pan Am 747 flight from Tokyo to Honolulu in 1982, damage to the aircraft was slight, and just 1 passenger killed. It was, however, a very different story when a bomb exploded on board another Pan Am 747 en route for America from Europe just before Christmas 1988. It blew up in mid-air over the little Scottish town of Lockerbie. All 258 passengers and crew were killed, and more than 40 houses destroyed. Indeed, it was relatively simple to prepare such a bomb and smuggle it aboard an aircraft, especially since only a small amount of explosive could have a catastrophic effect. Bombs, too, have exploded in airport terminals. The counter to air terrorism has been ever-increasing airport security. This includes the use of dogs specially trained to sniff out explosives. All baggage and all passengers are subjected to rigorous searches. While no security system can be totally foolproof, air terrorism has significantly decreased in recent years. The 1980s saw a new technology introduced into civil aviation. This is computerization of the cockpit, known as fly-by-wire, whereby commands are electronically transmitted to the control surfaces as opposed to by cables and pulleys. Indeed, many of the flight commands are computer-generated. The first airliner to incorporate this was developed by Airbus, a European consortium set up to compete against the American aircraft manufacturers. The Airbus 320 has just some 12 cockpit instruments, compared to the 40 or more found in a Boeing 737. American manufacturers began to follow suit, with the Boeing 767 being the first to use fly-by-wire technology. The 767 is a medium-haul, wide-bodied airliner with a capacity for some 240 passengers. It made its maiden flight in 1981. Under the 1978 Deregulation Act, US airlines suffered a major blow when they lost their legal protection against bankruptcy and competition on domestic air routes was opened up. Air remains the fastest and safest form of travel, but its only limitations are airport capacity and, crucially, the number of flights that can be controlled in the air at any one time so as to ensure safety. Civil aviation has dramatically speeded up communications around the globe during the past 50 years, and ever more people take advantage of this. Indeed, the world has become a very small place.